Good afternoon, everybody. This is Daniel Wieseneck. I'm presenting my presentation on mixed flow fans for building systems class. So before we get into mixed flow fans, let's go over fans in general and what the purpose of fans are. So fans are used over a variety of applications, and their purpose is to provide desired airflow that does not occur naturally, and to meet specific needs for varying applications, such as where high pressure or high flow are required in its setting. There are multiple different types of fans, with the two main groups being centrifugal and axial fans. And with that, we can get into mixed flow fans and kind of how they integrate into those two main groups. So mixed flow fans were developed around the early 20th century. It's an innovative design that creates a middle ground between two traditional types of axial and centrifugal fans. Fan was able to lead to a means to create efficient and compact air handling systems that is utilized over applications where medium static pressures are desired. As medium static pressure is higher pressures than what is typically able to be generated by axial fans, but is also lower than what is necessary for centrifugal fans and is able to be more efficient than centrifugal fans and those applications. On the right, you can see an exploded view of mixed flow fan. And one of the important things to note is how the sizing is very compact, with the housing holding the impeller and everything else kind of being based around that, and just that it's able to hold all of its components in a small space. The biggest design characteristic of mixed flow fans is their blades. It's what distinguishes them from the other types, and their blades are both axial and radial in how they generate airflow, and that's why they're called mixed flow fans. As you can see, it is angled and oriented in a way that will be able to generate high pressures and also maintain an efficient airflow. And with that, let's get into how this actually works and flow process through mixed flow fans. All right, so first things first, let's talk about how air is drawn into these fans. Air is drawn in the axial direction, which is how it enters parallel to the shaft at which the blades rotate. This is the same way in which the other two traditional types of fans intake air. Once it gets inside the housing and the impeller starts applying motion to the air, that's really see the flow conditions change and how that it differs from the other two types. So once the air is inside the housing, the blades on the impeller are able to induce both axial and centrifugal forces on the air due to the shape and orientation. The angle and twisted blades allow for the axial intake of the air while also inducing an outward push for the outlet. This results in the air experience an increase in the velocity, which is caused by the axial component, and an increase in the pressure, which is caused by the centrifugal component of the fan blades on the impeller. So air is ejected out of the fan in a swirling motion that is neither axial nor radial, but instead at an angle that combines both directions. On the bottom picture, you can see how this works. And this motion at which air is discharged maximizes the amount of airflow and the pressure at which the air flows at. And this ejection is able to be applied and is highly effective for applications requiring airflow over long distances. So the two traditional types of fans are able to generate different pressures and flow rates than mixed flow fans, and are going to be used in different applications because of this. So how do centrifugal fans work? Centrifugal fans work by intaking air in line with the shaft through the center of the fan impeller, and then imparting centrifugal forces that are able to be generated by this rotating impeller, and this pushes the air outward to the edge of the fan and changes the direction of the flow from axial to radial, and increases the pressure and velocity. Axial fans operate by moving air in a direction parallel to the shaft around which the blade rotates and expelling air in that same direction, as you can see to the right. This results in air that has been accelerated by the fan with low pressure increases, is mainly suitable for applications requiring a consistent flow of air over a specific distance. A key parameter that someone may use when designing or selecting a fan is the specific speed. What the specific speed is a dimensionless number that provides insight into the performance characteristics, including the flow the speed at which the fan rotates at, and the pressure it generates based off these other conditions. Axial fans typically generate the highest range of specific speeds due to them creating the lowest pressure increase while also creating a flow rate of air increase. Along with this, centrifugal fans have the lowest range of specific speeds due to them producing the highest pressure increase and the lowest flow rate increase. But there is a middle ground since the two kind of don't have overlaps in their ranges, which is the mixed flow fans, and it is able to generate that because it is able to have the ability to create an increase in both pressure and flow rate. Here you can see the pressure increase versus the air flow rate for the three different types of fans, with the most efficient operating conditions highlighted in the respective color. Looking at the blue highlighted region for mixed flow fans, which is also called diagonal fans, you can see that its operating range is somewhere in the middle between centrifugal's high pressure and low flow rate and axial fans' high flow rate and low pressure, and is used in applications where a medium static pressure and a medium or high airflow rate is wanted or desired. One of the main applications of mixed flow fans is inline ventilation systems. As you can see at the top right, that blue section is mixed flow fans. And one of the reasons that this is an application for mixed flow fans is due to the space constraint. Mixed flow fans are more suitable to achieve the goal of generating airflow than axial fans when space is a constraint. Another constraint that may be looked at when deciding to use axial, centrifugal, or mixed flow fans is the noise constraint. Mixed flow fans are more desirable because they do reduce noise when compared to axial and centrifugal fans.
So to conclude what we learned during this presentation, mixed flow fans are mainly distinguished by their blade design, which are able to create the unique airflow, as you see in the bottom right of the slide. And with that airflow, it is able to be created at higher pressures than that of axial flow fans. And also, we are able to consume less energy than centrifugal fans. And this is able to offer a middle ground between these two traditional types of fans. Here's my reference slide. Thank you all for listening. Hope you all learned something and appreciate your time.